heard few terms like AI. I think most of you have heard about AI, artificial intelligence. We have heard about terms like machine learning. We have heard about terms like deep learning, DL, in which we build our neural network architecture. We have heard about all these terms. So today we are going to just see what they are actually. Because in today's world, people just say these terms without having the knowledge of them. So if uh, imagine if this circle is AI. AI just simply means uh, let me just tell you about what is AI. You have seen that initially we have seen that when Apple just started building Siri, the programmers were used to write a lot of code to build Siri. So when we write code, when we write whole code, when we write each and every step, if else, full program, all the algorithms, data structure, when we write each and everything, that is part of our AI. In AI, we are not telling machine what to do by providing previous knowledge. For example, in artificial intelligence, we do not provide machine any previous knowledge, and we do not train machine. We do not train machine. We do not give any data to machine so that machine can learn from it. In artificial intelligence, we simply hard code everything and then we build our software. So this is known as AI. Machine learning is a part of AI. For example, let me change the color. Let me just draw it with orange color. If this whole circle consists of AI, then at today's present pace, this is known as machine learning. This circle is known as machine learning. And this circle is expanding uh, with a quite rapid pace. This circle is expanding with quite rapid pace, and one day it is going to fill the full AI circle. One day it is going to fully fill the AI circle. And let me tell you about what is machine learning. Machine learning simply means we are not writing any code. We have just few built-in algorithms which we use to train our machine. We do not write any code. We just train our machine on the past data or past outcome. In simpler terms, I would say that previously I have come across certain situations, and now I have learned how to deal with them. For example, if a small child touches something hot pan, so after touching one time, he will get to know that he should not touch this because this is hot. So what he is doing, he is learning something from his previous experience. So now we are making machines to learn something from previous experience that we are giving to machines. After machine learning, now let's discuss about what is deep learning. Deep learning is a part of machine learning. Deep learning is quite a hot topic in today's world. Deep learning is part of machine learning. In deep learning, we generally deal with neural networks. The circle of deep learning is expanding quite rapidly. It is expanding more fast uh, than the machine learning circle. And eventually we know that one day the deep learning and machine learning circles are going to completely fill the artificial intelligence circle. And let me also tell you about, actually, the machine learning is not a quite new term. Actually, machine learning was started in year about 1950 during First World War. It was started around 1950. As we know, the father of computer is Charles Babbage. So we consider father of machine learning as Geoffrey Hinton. Geoffrey Hinton. So we regard him as the father of machine learning. Let me also tell you something about Geoffrey Hinton. So machine learning is not a recent term. So let's search about him. Geoffrey Hinton. Oh. So actually he started all this machine learning thing back in 1950. So machine learning is not a really new term. It was started way back earlier, and now but we are using today because now we have the more computation power. For example, earlier we have only CPUs to compute our data, so we were not able to train our model. But now we have GPUs, even TPUs to compute our large data. So we have started shifting all our work using machine learning. So this was a brief description about what machine learning is, what artificial intelligence is, what deep learning is. So it is a brief description. If anyone is having any doubt, actually it is just a past history. You can find it online also. So the next topic that I wanted to tell you is next topic is in machine learning we have two parts. If I write machine learning, two or three parts. So the first part of machine learning is it is regression problem. Regression. First part is regression. Cool. The second part of machine learning is classification. Or wait a minute, let me just more reevaluate it. The first type of problem is actually machine learning has two parts. The one is supervised learning. Sorry, I was confused. One is supervised learning. And the other is unsupervised learning. It is unsupervised. Unsupervised learning. So supervised learning is also divided further. We have here we have regression problems that I'm going to write with REG, regression problems, and also we have classification problems. I'm going to tell you all about what are they. Regression problems, classification problems. In unsupervised learning, we have one thing that is clustering problem. Clustering. I'm having clustering. And yeah, we have only clustering. And the one more part of this problem is semi-supervised learning that we do not include in machine learning, but we regard it as machine learning. That is semi-supervised learning. Semi-supervised learning. Semi-supervised learning. So in semi-supervised learning, we generally have reinforcement learning. Reinforcement learning. So let me just tell you about all of these, this whole tree. So first of all, let us discuss about, let me change the color, supervised learning. In supervised learning, we have two things. In our data set, we have features. We have features as well as we have outcomes of that data. We have outcome of that also. Outcome also. In regression, we have few features of that data and their outcome also. Cool. In now let me just change my color, blue. So in unsupervised learning, we only have features. We only have features. We do not know what their outcome is. We only have features. Sorry for the wrong handwriting. I do not have the tab right now. So in unsupervised learning, we only have features, but what we do not have outcome. We are going to study about outcomes as we are going to proceed in our class. So I just wanted that you should know, you should have a brief idea of what we are going to do. So in unsupervised learning, we only have features. We do not have any outcome. Uh, uh, and and in semi-supervised learning, in semi-supervised learning, uh, we actually you all have seen that few players write script to play games. For example, few of the players write script to play games. For example, when you don't have an internet connection, you just open Google and a dinosaur comes up, that dinosaur game. Few people even write code so that the program can play the game by itself. So that is that is known as semi supervised learning. And we also call it as q learning. In semi supervised learning, we write code so that something can be done automatically. For example, let me tell you about supervised learning in great detail. Uh, uh, your learning examples. So you must have studied about Sudoku, N-Queen problem, and the games that player write code for. For example, players write a program and the program is eventually playing the game for us. So this is all known as unsupervised learning. If you want to know about more unsupervised learning, you can just refer to this Medium article. It's quite interesting. I think if I will give you a more depth knowledge of it, then the things will not be that clear to you. So we are just touching the surface today, and then as our course progresses, we are going to deeply dive into it. So I have told you about unsupervised and supervised. So we also know that supervised learning has two branches. Supervised. Supervised learning has two branches. One is regression problem and the other is classification. So in regression problem, what we have, for example, if I am having a graph and my values are like this. So what here I what in regression problem I'm doing is I'm just fitting a line which best fits all these points. For example, let's look at an example called house price. For example, this axis, let me say it is price of the house. This axis denotes price of the house, and this axis denotes the area of the house. So we know as the area of the house increases, then its price increases. So in supervised learning, we have few of the points and we only try to plot a line which best fits all the points. I'm not saying that the line will pass through all the points, but I'm saying that line will best fit all the points. So it is known as supervised learning. Supervised learnings are generally uh, um, they have continuous values. Supervised learning have continuous outcome. Uh, in supervised learning, I have told you about target that we know the target of the thing, what we need to predict. Target is what we need to predict. In supervised learning, we have continuous target. For example, here my house price is target and it is having continuous value. So supervised learning, we have continuous target. Uh, Whereas in classification, in classification, in classification, we also have target, but we do not have continuous target. They are divided into classes. Uh, for example, uh, uh, for example, we have in classification algorithms. For example, let's take an example whether the coronavirus is going to end or not. So what we are having outcomes in category. For example, let's suppose 0 means that the coronavirus pandemic is going to end in 2020, and 1 means that it is going to end in 2021, for example. So what we are having here is in classification algorithms, we have our target in different classes. So if I am going to make a graph out of it, it is going to lie on the x-axis when my outcome is going to be 0. Otherwise, it is going to lie here. Let me just draw a line. This line is y equal to 1. So otherwise my outcome will lie here. The outcomes are not continuous. They are in categories, for example. So these problems are known as classification problems. So the classes here I'm only considering two classes. The classes can be in any range, They can be 10, they can be 20, they can be more than 20. So the classes can have a wide range. uh, in today we are going to discuss we are going to see a data set of classification problem. We are going to see a data set of classification problem, then all these points will be more clear to you by then that time. So let me just share you the PPT and Nitish is going to tell you about the PPT. So let me present. Yeah, Nitish, you are ready?
Yes, yes. So you have seen that our output or target variable can be continuous or discrete. So we will take, we will divide our data into three forms: training form, testing form, and validation form. Firstly, we will train our machine on training data. Then we will create some validation set on which we can test our model, such that we can determine whether our function which have been determined while training can giving good results or not on validation set. That's then we can test on testing set. Okay, so you have seen that in supervised learning we are determining some function y is equal to fx. So we have to determine that function during training, then test on the validation set, then run on testing set. Okay, so while running on validation set, um, we do some hyperparameter tuning so that we can make our training successful. Okay, so this is known as splitting the data. Okay, so let me give you the example. Wait, 1 minute. So we can define our model like this. There is some training data, then we will define some algorithm which can be supervised or unsupervised. Then we will define some algorithm, and which algorithm will be best, that will be decided. Then we run our algorithm on testing data. So you have seen most of the websites on which the machine learning has been applied. So that are being running on our testing data. We have trained whole the model, then we deploy on the websites, then we run on the testing data. Okay, guys. So exploring data. This is the work of the data analyst. Mainly the work we have done tomorrow. In previous class, we have analyzed the data. This is known as the analyzing the exploring data. We will analyze our data. This work is mainly of data analyst, visualize our data and check which feature of data is not important, and will drop that columns. You will see in Titanic dataset that we will code today. So most of the statisticians and data analysts, uh, to improve the accuracy on the ML data, so they will remove the outliers which can decrease our accuracy and make correlation metrics which Shubham have told previously, and so that we can improve our accuracy. We can use for analyzing our data like Seaborn and libraries like Pandas for the correlation metrics and describe mean value, median value, so that we can analyze our data and can extract some important features.
During machine learning, we have these 5 steps: 1, 2, 3, 4, 5. So the first step is obtaining data. We can obtain data from various platforms, that is Kaggle, Google data sets. We can get we can use web scrapers. Few of the famous Python web scrapers are Scrappy and Beautiful Soup, that you can use to scrap out the data from sites, and you can generate your data. So during obtaining data, we get data generally of 2 types: structured data or unstructured data. uh, uh, the the structured data we generally get from Colab. We generally get from Kaggle and Google data sets, and we also have a UCI repository website that also provides us data. And unstructured data we get from web scraping. So after that, once we obtain our data, now our task is to clean the data, to remove the things that we do not require in our data. The next step, we just clean the data. After cleaning the data, now our task is to analyze what features are important, what things we need from that data, what things we need to drop, as Nitish told you. So in e just we explore and visualize our data to find out what things are correlating with each other. The next step is in that step we select a model to fit our data. So in that step we select we actually take more than one model, and we try to figure out which is fitting our data best. So this is modeling part, and after that interpreting our data. Here just we um, validate our things. For example, we check the accuracy of our model, that how my model is doing task, what is the accuracy of my model. All these things we are going to cover in our course. So let's move to our next slide. So if you are seeing this, these are the 5 steps. First we prepare our data, then we train our data, then we package our model, and then we validate. These 2 steps are generally needed when we deploy our model to a website. For example, if I am deploying my model to certain website to monitor what users are buying currently, so that comes into deployment. After that, obtaining data, we can, as I've told you, we can obtain data from databases. We can obtain data from various sites like Kaggle, Google Dataset, UCI repositories, and we can also scrap our data. So you can read all these things. Cleaning our data, we are going to see what cleaning is in today's class. In cleaning, we just remove the missing values or few values which have errors in them. We generally remove them or replace them by some other value. So this comes in our cleaning and scrubbing. Next is exploring. In exploring, as we have told, we are going to draw plot data. We are going to plot bar graphs. We are going to plot scatter plots to visualize what patterns we can find out from our data. Um, and I have already told you about supervised, unsupervised algorithms. As our class will progress, we are also going to evaluate our methods. So the evaluation part, in evaluation part, we generally check the accuracy of our model, how my model is behaving, predicting. So we check all these things. So next is updating model. Once we have checked the accuracy of our model, if we get a few more data points, then we can update our model. Then we can make our model to train on those data points also, and can enhance the accuracy of the model. So next is preparing a proper input output, that we are going to see this in today's class. We are going to do feature engineering today. So I don't think this is worth telling. We are going to do hands-on implementation on all these things. So before jumping there, first let me tell you something more important. For example, we have already seen that when we start C++ program, the first program that we encounter is hello world. C++, Python or Java, any of the language you start, the first program that you encounter is hello world. So let me tell you the hello world of machine learning. So there is a important article, this. Here I am just going to explain you about what is bias, what is variance, and what there is a bias variance trade-off that we are going to see today. So we are going to just see these 4 graphs. So let me take a pen. First, let me explain you what is bias. For example, I am having a data set. Not data set, let's take a more general example, that I'm writing an exam and I come to know that 90% of the answers are true, but I don't know which answer is true. But I'm sure that 90% of my answers, the answers are true, and I don't know which of them are true. So what I'm going to do is I'm going to mark all the answers as true. So it will ensure me that I will get a score of 90%. I think most of you have given JEE mains. For example, in JEE mains, if I tell you that A option is the answer A option is 90% answer of all the questions. So what you are going to do, you are going to mark only A option. That means you will get 90% marks in JEE Mains. So what this means? This means that my questions are biased. Questions are biased. This means that one of the thing is dominating over other. One of the thing is dominating over the other thing. For example, let's take off true false. My true is 90% and my false is only 10%. So what I'm going to do is I'm not going to waste any of my time writing a model. I'm just going to send a feedback that every of my answer is going to be true. I will not write any model. I will just send an output of true every time. So it will ensure me an accuracy of 90%. Are you getting it? So here the data is biased. It is just dominating one feature only. For example, in a data set, I have a data set of male and female where number of females are 90% and number of male are 10%. So what my model is going to do, my model is going to learn all the things about females, all the features about female, and it will discard the features which males have. So my one class is dominating other class. So it is known as bias. Now let's discuss about variance. Variance. Let us discuss about variance in quite a depth. So variance is, for example, I am getting a accuracy of 90% on my data, on the data on which I have trained the data. I'm getting an accuracy of 90% on trained data. And when I am testing my model, it is giving me accuracy of 80% only. So what this is doing is I'm having a difference of 10% and which is quite huge. So this is telling me that when I am having a bias in my data, for example, I have trained my model on only a female data set. And now I am asking the model about the features of male. So it is going to obviously give me few of the wrong answers. So so the difference between trained accuracy and testing accuracy is known as variance. This is known as variance. There is a variance of 10%. 10% variance. So these things we are going to see in this graph. So let me clear all these things and see. Now you have come across high variance, low variance, high bias when we have one majority feature, high variance when there is a difference between my mean training dataset accuracy minus mean testing dataset accuracy. So cool. Let us discuss. If I am having high bias and low variance, are you there with me, guys? I'm having a high bias, that is I'm having one dominant feature, and I'm having low variance, that means I'm testing only on that data set only. I'm testing on that data set only. So it is going to give me quite correct answers. It is going to give me quite correct answers. But these answers are not valid in real world, because in real world we are going to get data of a wide variety. So this model is of no use. We are going to get quite correct answers, but this is not valid in real world, because we are going to deal with a wide variety of situations. So this is our first case. For example, we are having high variance. So obviously it is not good, as we are getting a good training score and we are not getting a good testing score. So it is obviously discarded. Let's look at this situation. Here we are having low bias. that means we are having both the data as 50%, approx 50%, both data. Both data as 50%. But my model is recognizing each and every data point specifically. In this, my model becomes a super intellectual robot which recognizes each and data point individually. So what it does is, when I am going to test my model on the testing data set, so it is going to provide me answers of wide variety, so which are not that great. So it is going to provide me a very low testing score, but it is going to give me a very high training score. So it is also discarded. We do not use such models, and we are going to remove. We are going to remove all these things when we are going to start today's class. I mean, in coding. So the last thing I am having is I am having low variance and low bias. For example, I am having a model which is giving me accuracy of 90% on training data set. And it is also giving me an accuracy of suppose 88% on testing data set. So I am just only going to build such type of models which are having low bias as well as low variance. So now let us dive into hands-on experience. So what I'm going to do is we are going to take a classification data, that is Titanic data set. So what I'm going to do is I'm I'm just going to write Titanic data set Kaggle. Kaggle is a great platform. It provides all the data sets. So and we are going to code today in Colab. So it is our data set. So I'm just going to click over data. So here we have a data. It is containing a training set and a testing set. Both are in CSV files, comma separated files, comma separated vectors. So CSV files. So for downloading data, I can generally download data with this here. I'm getting here, download. Or I can download data by clicking here also. So gender submission CSV, wait a minute, this is the output. Let me just download the input files. CSV output. Input files are where? They might be here only. Training CSV. Okay, so I'm just clicking on training CSV and I'm downloading the files. And I'm also going to tell you how you can just get all these files in Colab also. I'm also downloading the testing CSV files. So all things are ready. Now let's go to Colab. And I'll just open a new notebook. These things are going to become more clear as we are going to practice. We are going to see a lot of projects on regression, classification. We are going to build up quite number of projects on both. I have downloaded the data set. Now I just wanted, so let me change the runtime so that things can run quite faster. So I'm just changing my runtime to GPU. I'm just explaining all these things in Colab so that I want you to migrate to Colab, because Colab is quite important for you. So today we are just going to see data pre-processing. So I'm just going to write data pre-processing here. So I'm just marking it out for you. Data pre-processing. Data pre-processing. Cool. So I have downloaded both CSV files and now I wanted to get files in my Colab. So I will click on upload folder and I'm going to select both the files and upload them. Okay. So both of my files are uploading. Both of files are uploaded. Both of my files are uploaded. Here is a question: what main drawbacks remain of Jupyter in reference of Colab? There is no drawback. Colab is similar to Jupyter, but actually, I am not sure whether you all are having GPU. So I want you to migrate to Colab because Colab provides you GPU where you can do high intensive processing. I think Karthik, you got my point. Okay, ठीक है. So as now I am having my data set also, and my collab is ready. So what I'm going to do, the first step of every data scientist, you need to import the libraries. So what I'm going to do is I'm going to import the basic libraries that we have studied. Import numpy as np. Cool. Import pandas as pd. Import matplotlib dot pyplot as plt. Cool. These are the basic libraries that I'm going to need, and we have also studied about them. Cool. My libraries are well imported. So now my second task is to read these CSV files. So what I'm going to do is I'm just going to create a variable data frame df. So I will take the help of pandas to read the CSV file. Read underscore CSV. Cool. Now what I'm required is I'm required here to pass on the path where my file is present. So I'm just going to right click here and copy path. Right click on the file and just going to copy path. And I'm going to paste over here as a string. So let me just write it as df train and the next variable as df test. So pd dot read underscore CSV. And now I need the path of the file. I'm just going to right click and copy path. And I need to paste this path as string. So cool, let's run it. Both my data sets are imported. Now I can just close this window. Close, let me close. Okay, now both of my data sets are imported.
Sir, actually, I have downloaded the dataset, but it can't be uploaded on that.
Yeah, you have downloaded the data set and
But I am not able to upload it.
first you need to click to the you need to connect to the server.
I am connected.
You have connected to the server, then you just need to click on this folder button and then upload. Folder button
The
and
files.
then upload, and then you are going to select the files which you want to upload and then just click on open.
Sir, file show ही नहीं कर रहा sir वहाँ पर.
Uh, uh, so just go to the folder where you have downloaded the file.
Sir, whenever I close that server, it is showing the file, but whenever I use to upload it, it can't be shown.
um, um, I'm just asking you in your PC where you have downloaded the file.
In downloads.
You have downloaded the dataset.
Yeah.
Okay, someone is saying I need to just tell how I downloaded that dataset. So what I'm going to I'm just going to search Titanic dataset and Kaggle. Cool. So let me just tell you from the start. So I'm just going to go on Titanic. And guys, I'm sorry, there is a construction work going near around my house. So I'm just sorry for all the noise that you are getting. So I have opened this page. Now I'm just going to click on data because I need the data. And then I'm just going to click on train CSV. And after clicking on train CSV, here I'm getting a download button and I'm going to click download. So my data file will start downloading. And then I'm just going to click on test CSV. And then in a similar way, I'm just going to download it. So these are the steps to download dataset. After that, I'm just going back to my Colab. Let me just restart my runtime. Let me just interrupt execution and restart my factory reset runtime. Cool. I'm just doing a factory reset so that you all guys can come with me. So what I'm going to do is I'm just going to press here connect. You are having connect and I am having reconnect. So once this is going to connect, so it is initializing. Now I'm connected to the Colab server. Now what I'm going to do is I'm just going to click on upload and select the files which I have downloaded, and then I'm just going to click on open, and both of my files will be shown here. If you are not viewing the file, then just click on refresh button and you are going to see them. If you are unable to view the file, just click on the refresh button and they will appear. Just click on the refresh button and they will appear. If you face any further doubts, you can just contact all the commenters.
So now it's working.
Yeah, cool. So what I'm doing is, firstly, I'm just importing all the files, and now I'm importing all the data set. Now my first task is to see the data set. I'm just going to write df.head, and I'm just going to see 10 rows. Oh, sorry. The variable name is df_train. df_train, cool. So let's view the 10 rows of our data set. Just give me a time to just rearrange the things. So let me just tell you something about this data set. So in this data set, I am having passenger ID as a column, survived as a column, P class as a column, name as a column, sex as a column, age as a column, SIB, SP as a column, parch as a column, ticket, fare, cabin, and embark as a column. So in this data set, I am having few of the values like NAN. NAN. Yeah. I'm having few such values like NAN. So these are just corrupted values. You can just simply say them as corrupted values. These are the missing values and we need to work to remove them or to replace them. We are going to do that in today's session. So this is our data set. In this data set, Embark is having few categories, like it is having S, and a C category and a Q category. So it is having few categories, and we can see that the fare of the ticket is in continuous range. This is ticket number. So the people who were just there on Titanic, they must have known about it. So this is ticket number. Parch actually I don't know what parch is, so we are going to see what it is. SIB, SP is number of siblings. How many group? It generally means group. So how, in what group you went on to the ship. Age is just defining the age of each and every person. This is the gender, whether the person is male or female. This is the name of that person. And few of the columns like P class. This is one of the important column. Survived. We are going to deal with it. So this column, we call it as a target column because we are going to finally predict whether the person is survived or not. So this column is called target column that we were studying earlier. So this is my target column, and in survived I'm generally having 0 or 1. 0 means he did not survived, 1 means he survived. Cool. And then I'm having a passenger ID which is from 1 to last. So after seeing these things, now let us see more of the things. Let us see more of the things. For seeing more of the things, let us see how many number of rows and columns are there. For seeing that, I will just write df dot underscore train dot shape. Cool. So it is showing me it is having 891 rows and 12 columns. Cool. So what I till now I have come to know that there are 12 columns, 891 rows, and few of the basic functions of that data set. So now now we have studied about the few functions of data set. Let us explore those also. For example, df underscore train dot info. The things we have studied in previous class in pandas, we are going to just see all those things. Let me just zoom it for you. So we are having passenger ID as a column, and it is having no null values. All the rows are filled with correct data, and all the rows are having int data type. Cool. Then we are having survived as a column. All the values are correct. There is no incorrupt data, and it is also of int type. The next thing is P class. P class, it is also having all the rows filled with correct data, and it is also of int type. Now we are having name. Name, all the names are filled, but it is of object type. Here it is written object because all the values in this column are of string. For example, if I go back and I tell you here the name is stored as a string, it is not stored as a int or float. So it is showing it as an object type. It will show string as an object type. Object type. Cool. So next column we have sex. It is also of object type. Age is of float type. Number of siblings is also of integer type. And let us see this. The non-null values of this column are 714 only. This means this column contains corrupted values or NaN values. NaN values that we have seen right now. So this column contains corrupted values. For example, this column contains corrupted values. This column contains 2 or 3 corrupted values. So you can just see what type of values this column contains: float, string, int. You can just see from here only. So we have now got a few more knowledge from df underscore train dot info. Next thing we can do about is we have studied a function called describe. Let's explore that also. I'm just going to write df underscore train, and let's describe it. So when I'm describing it, I'm getting few of the as I have already told you, describe only shows me column which do not have string values. For example, let us see cabin. It is not showing me an cabin. Are you getting it? It is not showing me cabin. So it will only show me the columns which are having string values. So cool. I'm having passenger ID. Count, all columns are filled correctly. For example, here all columns are not filled correctly. There exist few corrupted values. Otherwise, all columns are filled correctly. Cool. The mean value of this column is this. Similarly, mean value of this all the columns are given here. we are having standard deviation also, and the minimum value is 1 and the maximum value is 891. As you can see, a passenger ID start from 1 and will end to 891. So we have told you a quite in depth about 25%, 50% and max. So all these things gives me insight that I need to work on few of the values which are encrypted. My first target is to work on the values which are encrypted. So while working on the values, and also one of my target is to remove the column which are waste for me. So before removing the columns, let us see what columns I'm having. So I'm just going to write df underscore train dot columns. So it is going to give me list of columns present. Cool. Now I am having list of columns. So I'm just creating two list L1 that I'm going to call. I'm just writing L1. L1 is my list 1, and let's leave it to L1. L1 is the list of columns that I'm going to drop. So I need suggestions. Which column should I drop? Should I drop passenger ID? I need more answers. Shidesh is saying yes. Okay. So before dropping to passenger IDs, let me just tell you a story. For example, if you are sailing over a boat, over Titanic only, if you have been over Titanic, um, um, and I am having my passenger ID as 123 or any of my passenger ID, would it have been mattered whether I am going to survive or not? Are you seeing any trend whether the person having higher passenger ID have survived or the person having lower passenger ID survived? I think in Titanic, the priority was given to women's and smaller children's first. They were not given priority over their passenger ID. So the people who survived were generally women's and smaller children's. And the person who were helping them, they were not actually checking their passenger ID. They were only checking whether the person is female or a small children. So I think passenger ID is of no use. So I am going to drop it. Cool. Let me just copy that. I have not copied that. So I'm selecting here and pasting it out. If you are feeling shy, then you can just privately message me. Otherwise, I think there is no need to feel shy. So our next column is survived. How many of you think should we drop it? Shidesh is saying no. Yeah, you are on the right track. We can't drop survived ID because it is our target value that we wanted to predict. So we can't drop it. The next is P class. How many of you think that P class we should drop? Sidesh is saying we should drop. Bhupender is saying we should drop. So in Titanic movie, we have seen that the person who is having the class first, I'm actually not getting, the richer person were having class third. No, the richer person were having class first, and the person who were poor were having class third. So in Titanic movie, actually the richer person were able to survive. So I think the P class has a great impact whether the person is going to survive. If the person is going to belong from the class first, then the chances of surviving that person will be more, because the persons in the richer class were given favor. They were given boats to escape from the Titanic. So during visualization, you all need to just gather full information about the data set. So P class, we are not going to drop. Cool. The next is name. How many of you think that we should drop name? Those who think, just write drop. Just write drop. Okay. Yeah, I'm getting quite a good number of drops. So if I think of name, I think of um, we, the names can be of anything. A richer person can also have a name, same name as of a poor person. So we cannot distinguish people. We cannot distinguish whether a person is richer or poorer according to their names. And also we cannot distinguish a person over the name whether he is going to survive or not survive. So actually we are going to drop name. So let me just copy it and I'm pasting it out here. Cool. So we have selected two columns that we are going to drop. Do you think we need to drop this column, gender column? No. Yeah, you are just guessing it right, because the women's were given priority over men's. So I think this column can have a great impact on my output. So I'm not going to drop this column out. Do you think I should drop age? No. Cool. I think you are getting it. Do you think I need to drop siblings? Whether the person is having siblings or not? Uh, yeah, you are saying 50-50, so we are not dropping it. Few of you are having concerns, so we are not going to drop it. Cool. Parch. Do you think I should parch?
Parch parent children है, parent children.
Parch. Let me see.
Parent children.
Okay. So, do you think that should I drop it? Yeah, I'm also having no knowledge about it, so I'm not going to drop. So cool. My next column is ticket. How many of you think that I should drop ticket? This is my ticket column. Before dropping tickets, let me give you a correlation between ticket and fare. The person who is paying more will have a different ticket type. Are you getting it? The person who are paying more will have a different ticket type, and the person who is paying less will have a different ticket type. So I think ticket and fare are same. So I'm just going to drop ticket and I'm not going to drop fare. Those who think I am right, just write fare in the chat section. Utsav is okay, cool. So I'm just going to drop the column name as ticket. So let me just select it out, copy and paste. Cool. I'm not going to drop fare. Now let's see cabin. Cabin. Do you think I should drop cabin? But doesn't fare signify the class? Yeah. Fare signifies the class. That's why I'm not dropping the fare. Yeah, Karthik, you are right. The fare signifies the class. That's why I'm not dropping the fare. Cool. Cabin, I don't know what cabin must be related to survive. So I'm not going to drop cabin. As well as I'm not going to drop embark also. So these are the columns that in first go we decided to drop. Still we have not started any feature engineering yet, what we come to know that these columns are not necessary for me. So we are going to drop passenger ID, we are going to drop name, and we are going to drop ticket. So let us drop these columns. So first me run this cell. So now what I'm for dropping the column, I'm just writing df underscore train dot drop. Cool. Here I'm just going to pass the list of column that I wanted to drop. So I'm just going to pass L1, and let's run it out. L1 passenger. Oh, access is not defined. Sorry. Let me define the access also. So for dropping column, my access is always 1. We have seen for dropping column, access is 1. For dropping rows, access is 0. We have seen that out. So I have dropped the column. So I have dropped them out. So if I'm going to just write df dot head, df underscore dot head, or df underscore train dot head. Sorry, I don't know what is going in my mind. df underscore train dot head. See, I have dropped these columns, but still they are not being dropped. So there is an important parameter in drop. That parameter is in place. In place parameter that you can see here. This parameter. By default, the value is false. It means that it is just going to drop all the columns, but it will not going to reflect back on my original data set. So if I want the changes to get reflected to my original data set, so what I'm going to do is I'm just going to write here in place and going to set it to true. So now let me run it again. I have run, and now let us check our original data set. So cool. So now I have dropped. So I need to drop all these columns from my test also. So what I'm going to do is I'm just going to copy it and I'm going to paste over it. And I'm just going to change from train to test. So df underscore test, I need to drop these columns from my test also. So cool. You have seen this error. It is saying that there is no column in this df underscore train, as we have already dropped the column. So it is giving us error that there is no column name with the list that we are providing. So I'm just commenting it out and running, as we have already dropped. So now I can uncomment it. Cool. So I have dropped everything and my data set looks great. So now let us move to next thing to see. Yeah, we can see a function df underscore train to check what unique values this column contains. So the function was nunique. Nunique. We are going to run it. So what this is showing me, it is showing me that survived is having only 2 values. We know that the survived is having 2 values, 0, 1. That is a person survived or not survived. Similarly, P class is having only 3 unique values. Simply gender is having only 2 unique values, that is male, female. Age is having 88 unique values. Fair is a continuous fair is having continuous value, so it is having more unique values. So from here we are getting to know that embark is having only 3 unique values, parch is having 7 unique values, number of siblings having 7 unique values, and gender is having 2 unique values, P class is having 3 unique values, and survived is having 2 unique values. Cool. Now let's and after seeing all this, and we have also seen our data. So the next thing we wanted to know is, so we have seen the number of unique values. For seeing number of unique values in each column, what I'm going to do is I'm just going to write df. Just going to for example, I need to see the unique values in Embark. For example, I need to see the unique values in Embark. What type of unique values it contains. So I'm just going to copy Embark and going to paste over it here. And I'm just going to write dot unique. Dot unique. So running it out, df is not, sorry, df underscore train. I don't know what is going in my mind. So let us run it. See, it is giving me an array which is saying S, C and Q. So Embark is having 3 unique values, as well as also Embark is having NaN values. So now let us see a function. Now our next task is to remove all the NaN values. So before removing the NaN values, let me just give you a task, and it's open mic. For example, I am having table, a data table in which one of my column is having 80% corrupted values. One of my column is having 80% corrupted values. So from you, I'm asking whether should I drop this column, or whether should I drop the rows which are having these 80% NaN values. So we can only drop column or the rows. We can only drop column or rows. And one of my column is having 80% corrupted values. So you want me to drop the full column, or you want me to drop all the rows which are having these corrupted values?
Column.
So majority of you are saying column. Column should be dropped as it is easier. No, we can drop rows also. Rows is also easier. Dishika, rows is also easier. There is a function called drop NA, and it is going to drop that full row for us. All the rows for us. Drop NA is going to drop all the rows for us. It's easy. So Bhupender is saying rows. Cool. I'm getting your answers. And I think after getting your answer, I should explain more things to you. So see, for example, suppose I'm having 5 columns, or 3 columns, only 3 columns, so that I can just explain it fast. A, B, C. 3 columns and 4 rows. It is containing 1, 2, 3, and 4. It is containing, for example, A, B, C, and again A. Suppose it is containing a value 10, and here the value is corrupted, here the value is corrupted, and here the value is corrupted. So if I'm just going to drop my column, then I'm going to just lose only this value. Are you getting it? If majority of my values in a column are null, if I'm going to drop column, then I'm going to lose only this value. But on the other hand, if I'm going to drop all the rows, then I'm going to lose all these values. Then I'm going to lose all these values. Are you getting it? These data can be of real importance for us. We know that in data science, data is most important for us. And what we are doing is we are dropping more data. So we need to drop less data. So when the NaN values in column are approx 80% or 90%. So what we are going to do, we are just simply going to drop that column. If, for example, this my column is having 20% NaN values, then what we are going to do is, then we are going to then we are going to replace the values. Then we are going to replace all the values. Cool. On explaining this, let me just explain few more things to you. Which are related to this concept only. Let me just erase few of the section. Cool. Let me just erase it out. Cool. Instead of also, let me just erase few more part. For example, I am having here value, corrupted value. I don't need this pen. Cool. So what I'm saying is I am having here corrupted values, and I am having here corrupted values, and I am having here values 10, 8, 4, and 6. So in this situation, what I am going to do is I am going to drop the column. I'm going to drop the row. In this situation, I'm going to drop the row, because on dropping row, I'm just going to lose this data, and my majority of my data will be preserved. Are you getting it? So we are going to drop in such manner only. And if my data is lying between 10 to 20%, then we are going to feature engineer. We are going to just replace that data with some other data, or we are going to see it in the next step only. So we have a function in data frame. Let me just write it out. df.train is null. Is null function. So this function has given me a table. So this function will return me true where the value will be corrupted. For example, it is saying here the value is corrupted. 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 It is just going to return me true where the value is corrupted. So I just need the count so that I can check where my values are corrupted. So I'm just going to write a function dot sum, which is going to sum. For example, it is going to sum over this column and find out how many trues are present. It going to sum over this column and find out how many true are present. So it is going to traverse the column and will find out number of true present in that column. So let me just run it. So cool. We are getting things. We are getting quite good results here. So it is saying that Kevin column is having 687 corrupted values. So let me just run df underscore train dot shape. Out of 891 columns, we are having 687 column corrupted. So I think we can clearly drop this column. let's make a list of L2. So this L2 list tells me that I have gone over my data and I have seen the concept that which data I should drop and which data I should not drop. So I am getting that Kevin should be dropped. Cool. Kevin. L control V. Oh. Cool. I can make a insight that Embark is having only two values. So we cannot drop the column. There are only two options. We can remove both the rows, or we can replace those values with some another value. So Embark is having only two. We are having age corrupted values of 177. So neither we can drop the column nor we can drop all the rows because of few corrupted values. So we are going to feature engineer that row. So so for dropping the column, so we are going to do a smart work. We are just going to paste the code that we have written. Copy. We are just simply going to paste the code here. We need to drop only one column. So, and I'm just going to replace my list with L2. L2. Cool. Cool. It has been dropped. Cool. Now let me just again print my train.head. Cool. See, the column has been dropped. Cool. Now we wanted to replace the age value. So let's deep dive into the age column. So let us check what is present in the age column. Train dot. We need to see the age column. Age column. Cool. See here. When I'm just displaying my age column, I'm just seeing that there is one NaN values, or I have printed it out also that how many NaN values I'm having. Now in this age column, I need to replace this age with something else. So can anyone suggest me what I can use to replace this age? Can anyone? It's an open mic for you. You can just open your mic and say it out loud. One. Karthik, I just need a reason why you want me to replace our age with one.
So maybe with the mean age.
Yeah. Average also. Cool. So when we are feature engineering, we can see that my age is having continuous value. So in continuous values, I have seen few of that things like mean, median, and mode. So not average, I can replace my age value with any of these things. And according to situation, I will get to know that how I need to replace the values according to situation. So here we are having a continuous data. So what I'm going to do is I'm just going to use the mean. For example, I'm just going to use the mean to replace all those values. So let me just replace all those values. Clear and close. Cool. So for replacing all those values, the pandas provide me a function, simple function, which is known as fill NA. Cool. So what I'm going to do is I'm just going to write train. Oh, sorry. df underscore train. And which column I'm going to is I'm going to use the age column. And in this column, I'm going to dot fill NA. Cool. So I am having this column, and now it is asking me to give it the values which to give it the value that it need to replace with. So it is asking me to give it the value that it need to replace with. So before let me just cut it out and let me show you. If I write here a mean df underscore train of age dot mean, so what it is simply giving me it will give me the mean age, and I want it to replace with my mean age. So what here I'm going to do is I'm just going to write df underscore train of age dot fill NA, and you have seen I need to fill it with the mean age. So I'm just going to copy it up and going to paste over it here. Control V. So it is having one more argument that we have seen earlier, that is in place. Whether you want to reflect the change to the original data set. And yes, I want to reflect the change to my original data set. So what I'm going to do is I'm going to replace it. And when I'm replacing it in training, let me also check out the whether how many NANs are present in my test also. Cool. There are few columns in my test also which I need to replace the value with. So I'm just going to copy it and do the same for test also. Because there should be uniformity between my training and test also. So I have done it. It has replaced the values. Let me just run it for test only. See, the age section has no encrypted values now. And I can also check it for train also. Cool. Here also my age section is completely good. So now I have only two values. So can anyone suggest me whether I need to replace this value or should I drop both rows? Whether I need to replace this value or should I drop both the rows? Both rows. Okay. Replace. Okay. Karthik, can you tell me why I need to replace? Karthik, because of importance of data, maybe. Okay, you are quite getting the concept. So let me check out the unique values that are present in Embark. Yeah, you are saying correct. I need to replace it because I will lose my data if I'm going to replace it, remove it. Yeah, I need to replace it. So let me just first check the values that I'm having here. Why I'm doing this thing again and again, df underscore train. So I'm having here these values S, C and Q. So Karthik, my question is to you. I cannot find mean here. I can find the uh, mode here, the value which is coming more frequently. So I can replace this value with mode also, and if I wish, I can drop the column also. So for replacing this value with mode, so what I'm going to do is, instead of unique, I'm just going to write here mode. See, it is giving me value S, that this value is occurring more frequently. So there is a possibility that these two rows must be having this value only. So there is a bit probability, more higher probability that these two rows might be having this value only. Yeah, Karthik, you are right. We can replace it. We can replace it, but here I am not going to replace it. But if you are doing in your future project, then you must replace it. Here I am not replacing it because I just wanted to teach you how you can drop the rows also. Are you getting my point? Till now, if you all are getting my point, we can replace it, but we are not going to replace it, so that I can tell you how you can drop the row, how you can drop the specific row. So let us drop the rows. So you have seen the trend. First we dropped column, then we feature engineered it, and at last we decided to drop rows. So for dropping rows, it is simple, right? df underscore train dot drop na. So drop na has an parameter of x is 0. By default x is 0 is 0. By default axis is 0, so it is specifying me that it is going to drop rows. And how any means that it is going to drop all the rows that are containing nan values. But I'm interested in this argument in place. I need this to reflect back into my original data set. So what I'm going to do is, I'm just going to write here in place equal to true. I just need to change only one argument because all the default argument are satisfying my conditions. True. So let me just run it. And if I'm dropping it on the test also, so I need to drop it on the, if I'm dropping on train also, I need to drop it on the test. But before I'm going to drop on test, let me just see whether my train has been dropped. df dot underscore train dot is,
Excuse me, sir.
yeah.
सर इसमें हमें ये मेंशन नहीं होना चाहिए कि हम एम्बार्क्ड वाले ही वो रोज
No,
करेंगे.
actually it is going to drop the row. Are you getting my point? It is going to drop the row. A row is having a values from all the column.
No, sir, I am saying, but wouldn't it be, wouldn't the computer understand it like this, that all the columns having NaN in their rows, all of them have to be dropped and not just the embarked wali?
No. Actually, I'm not about considering any column here. Here, what the thing is happening here, the computer is going back. It is checking every row. If that row is having any of, if in a row, any of the column is NaN, it is just dropping that row.
Okay.
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 Yeah, it is just dropping that the row. Now you can see that my data is clean. I've done pre-processing quite well. Let me also check it for the test also. Test. Cool. Test is having one missing value, that is fair. So let me, lastly, I dropped on embark. If I run the same line on test, then it is going to drop fair also. So it is going to make it out a bit more clear. For example, I'm just going to change here test and drop. So let me run. Yeah, see, it is not checking whether a column is having, it is traversing the row, and if any of the values NaN or encrypted, it is just simply dropping it. So cool, now we have just cleaned our data. On, I'm just going to move towards the next topic. My data cleaning is complete. My data cleaning is complete. Now I just need to do few more things to complete my data pre-processing. Cool, I think majority of you are getting it. Now, for example, if I'm going to pass this data to my machine, then my computer don't know what mail is, because my computer only works on numerical data. It works on numerical computation. So my computer don't know how to deal with all the strings. My computer do not know how to deal with all the strings. So before dealing with the strings, first let us draw few of the graphs. Then we are going to move to topic called label encoding. Till now we were just cleaning our data. Now we are going to do label encoding. So before doing label encoding, let me just draw a graph. For example, let me just write something and then I explain to you. Train. Control C. Control V. My survived is having values 0 and 1. For example, I wanted to compute it to this. Now let's see what it is giving me. It is giving me 549 rows. Instead of, I can here also print, let me just also print df.shape also. And the things will become more clear. Underscore train.shape, cool. So my final data has 889 rows, but when I have written this, it is only giving me 549 rows. So what it is doing is it is giving me all the rows where my survived value is 0. For example, you can see that whenever I am getting all the rows with my survived value 0, if I'm just going to write it here 1, it is going to provide me all the rows which is having survived value 1. For example, see, my number of rows are 340 only. So I can, this kind of works as a if statement also. If statement also. And if I wanted to specifically check how many of the people survived in the, let me just write it and then explain. Let's see what this gives. Cool. So I think most of you have understood about here. Most of you have understood. This thing, you are not getting this thing. So let me just move back and cut this thing and then explain. Cut and run. Actually, it is my data frame only. This line is giving me my data frame only. A copy of data frame where my survived value is 1. A copy of data frame in which my survived value is 1. A copy. I'm saying copy, not original. I'm saying copy. So copy of data frame where my survived value is 1. Now, if in a data frame I need to specifically look a column, what I used to do, I used to just paste square bracket and column name. So if I just wanted to see this column, so what I have done is, this is my whole data frame, and I am just seeing a specific column out of it. Are you getting it? So it is giving me a specific columns where it is giving me a gender. These have survived because my survived is 1. If I'm going to change it to 0, this is going to give me a column, the peoples which have not survived. Now let us draw few of the plots which I need so that we can just get a good knowledge about the data. Let us draw few of the plots, and I am just defining a function graph in which I am just going to pass a column name and it is going to give me a plot. Cool. I'm defining a function in which I am going to pass a column name and it is going to give me a plot. And for doing the plot, I'm also going to tell you one more thing, that let me just tell you something. Actually, we cannot plot data frame directly. So pandas provides us a thing known as df.plot, a plot function. Pandas provides us a plot function. Not new tab. Actually, I need to open here. Df.plot. So you can check the documentation of any function. Actually, pandas provides us a plot function. So actually what we cannot plot data frame directly. So what panda decided that it is not going to need any help from matplotlib. It is going to generate its own plot functions. What it is having, it is requiring data x, y, kind. Kind is a string. Whether you wanted to draw line plot, bar plot, histogram, box, density, area, pie, scatter, you can draw any kind of plot. So pandas said that it is not going to depend on matplotlib and it is going to define its own plot function so that you can plot it out. So let's do the plotting. So let me take few variables. For example, SUR means the person who survived. Cool. So what I am going to do, I am just going to write df_train of df_train of survive. Survived, I can see. Cool. Survived, the value should be equal to 1. And I need this column. I'm passing the column name. So as I'm going to call the column, so this s variable is going to change its value. S is a variable. So I'm defining a dead df_train, or I should write it as passed. df_train, and I need a column survived. Survived, where the value is equal to 0 of s. Till this thing, I think this might be clear to you. Then I'm creating a data frame out of both these columns. So for creating data frame, I had a function pd dot data frame. pd dot data frame. Here I need to provide the data. I need to provide the data in and many more other variable arguments. So only few of my arguments are important. So I'm just going to provide data. That which data should it plot. So here my data would be this column and past column. Cool. So let me also print the df. So I'm just going to write print df dot head. So let us just see what this is doing before plotting. So what I'm doing is I'm just writing a graph and I will pass here as a string. For example, I will pass here as gender only. So let's see what this shows us. So it is actually okay. It is making a data frame. Why I'm getting this NaN values? Let me just see df dot head. Cool. I need two columns with survived and passed, and I'm getting these two values. Cool. Actually, print function is not showing me the correct output. Let me check if df dot head shows me. Df dot head. Actually, it is not showing me the output, but let me just generate the graph, then it would be more clear to you. So graph is df dot plot, and in kind function we are going to pass as I want a bar graph, and it is having one more argument as stacked. It is having stacked, which I'm going to specify as stacked, and I need a stacked graph. I need both of these to come in one graph. So I need to provide it true. Cool. So my function is ready. So let us just plot the graph. Actually, no numeric data to plot. Okay. No numeric data to plot. Let me figure out. Okay. Sorry. Yeah, it is saying no numeric data, because if I am going to run it out, let me just show it to you. Yeah, the control Z. The compiler is quite right. There is no numeric data. Let me just change here to. Cool. So the compiler is quite right. There is no numeric data. There is only string data. So I need to change it to numeric. If I will write here dot value count. See, let's see what this gives us out. Okay, there is a function value count. Value counts. Sorry for the typos. Value counts. So it is giving me two value. It is giving me females. Females are 231 and males are 190. So what I'm doing here is I'm just going to write dot value underscore counts. Control C. And now I think that dot. Now I think I can just show you the df dot head also. Print of df dot head. Now I think I can. I've compiled the function. Let's run the graph function. So it is giving me a data frame, which is the first is survived one, and the second ones are died. So the females are 231 females survived, 81 died, and out of male, the majority of the male died because the priority was given to women's. So I think the data frame is generating now values. So let's get over to this function and plot the plot. So now you are going to see a good plot of this function. Cool. So what I'm getting is see here. This is showing us the value that survived, and this is showing us the value that died in the Titanic tragedy. So you can see female is represented with blue colors. So most of the females survived. Most of the females survived, and only few males were able to survive. But most of the male died, but only few females died. And you might be wondering why I just changed it to stacked. If I removed it from stacked, then you are going to see splitted values. I just wanted to merge both of them. If you are comfortable with this, then I can just stay over it here. It is also giving us quite good details. So majority of the females survived and majority of the male died. Now you are just getting the correlation that when the feature is going to be male, the probability of dying is more. When the feature is going to contain female, then the probability of dying will be less. Are you getting it? Now let's draw our next graph. So in this graph, I'm going to pass the categorical variable, the column name. So let me just take out the column name. Okay, let's see what is there in embarked. So when I'm doing this, I'm getting a good graph of embarked also, where this blue is representing my S class, orange is representing C class, and this is representing my Q class. So you can see that the more S class people were able to survive, the more S class people were able to die. So you can see a directly proportional trend. You can just see a directly proportional trend. We can also draw on any of the columns which are having category. For example, we just wanted to draw on this column. This is having category. So Control C, and we can draw graph. Cool. That you can see. So it is, this color is representing the people which are having 8 siblings. So it is showing us the people which are having 0 sibling were the people who survived most. Here also you can see the people which are having 0 siblings were survived most, and the people who are having 1 siblings also were able to survive most. The people with 1 siblings also died less if you compare the both the graphs. So they give us a great deep inside the data set and encoding from where we have started. Encoding, cool. So in label encoding, what we does is, for example, here I am having a gender column in which there are 2 values. I will write M for male and F for female. M, F, again M, again M, and all these values I am having. In label encoding, what we does is, for example, I am having a column, gender column. So what I'm doing is I'm just having string values, male, female, male, male. So my computer cannot recognize what male is, and he cannot perform any task over it. So what I'm going to do is I'm going to convert all the males to 0. and all the females to 1. Are you getting it? So that my computer can recognize that 0 is for males and 1 is for females. So the conversion of from string to label is known as labeling. The conversions of label to a number is known as label encoding. So this we are going to see. Let me just clear all the drawings. Let me also print my data set. Let me just print my data frame. Sorry. So df underscore train dot head. Train dot head. Cool. So the columns which I need to label in code. The columns which I need to label in code are sex and embarked. These two columns I need to label in code. So for doing label encoding, sklearn provide us few of the greatest packages that we can use. sklearn is very important. So what I'm going to do from sklearn dot preprocessing. Preprocessing import label encoding. Label encoder. Yeah, it's label encoder. So let me run this cell. Yeah, label encoder has been encoded. So what I'm going to do is I'm going to create two object of label encoder, le underscore s4 sex column, and what I'm going to do is I'm just going to call that class over here, label encoder. Let me just write it and then I'm going to explain it to you. And embarked, for embarked I'm just representing it with capital. The object of my the object to encode my embarked column is le underscore capital E, and I'm just calling the label encoder class for it. So till now I have created two objects. Two objects, and I'm two objects of label encoder class, but I haven't told them to label encode which of the column. So for label encoding any such of the column, what I'm going to do is I'm just going to write df underscore train of column name. So column name is this. So I need to label encode this column. So for label encoding this column, I'm just going to call the label encoder object, and I will just write dot fit transform. And as a parameter, I will pass the values. I will pass the values to be label encoded. I will pass the values that I need to label encode. df underscore train let me write it for both the function, and then we are going to see what they are doing. It's control me. Cool. So let me just run this and then again print my data frame, and then we are going to discuss what they are doing. Cool. Now what you are going to see that the labels of my column have been replaced. What you are seeing? You are seeing that the changes have been made. For example, I am having male. Male is represented with 1 and female is represented with 0. Cool. male is represented with 1 and female is represented with 0. You can see all the changes. And also in Embark, my S is represented with 2, C is represented with 0, and the next Q must be represented with 1. Are you getting? If you are getting the label in code, and one more thing I need to tell you about this. I need to tell you what I'm doing here, dot fit transform. Actually, we have three methods. We have three methods. Let me just rub all this. Actually, we have three methods. First method is only dot fit. First method is dot fit. Next method is dot fit transform. I'm just writing fit transform as underscore ft. And my third method is dot transform. I'm also writing transform as underscore t. Transform. Cool. So what my fit does is it is going to analyze my data. It is just going to analyze my data and will not create any changes and will not make any changes to my data. It is just going to analyze and get that inside of my data. It is just going to analyze and it is going to check how many categories are there in this column, and it is going to give every category a specific value. So it is just going to analyze. And what my fit transform does is it analyzes the things also, and plus it also changes, it also makes changes. It also makes changes so that you can look here. It analyzed that this column has two category, male and female, and it also created a change in them. It also changed those values. And what my transform does, my transform only changes the things. It does not analyze anything. If I analyze something, and then I can transform all the things with the help of previous knowledge. I can it only changes. I will make it more clear if when I'm going to just change the testing data. We have created a change in our training data. Now let's create the change in our testing data also. So we are just going to copy these things. I'm just going to paste it over here. Instead of train, I'm just going to write test. Here also, I'm just going to write test. And here I'm just going to write test. But instead of fit transforming, I do not want to analyze the data. I have analyzed my data one time, and now I just wanted to bring the changes. So I'm not going to fit, I'm just going to bring changes. Cool. So after doing this, the changes is going to reflect in my test also label made. Let me check where the mistake is. Line 65. No. Y contains previously unseen label male. Let me just see. Wait a minute, I have made few of the mistakes. Let me just tell you something. Actually, this object was to change the values of gender only. So I am using it to change gender, and then I am again using it to change other values. So when I am using it to change other values also, so what it is doing is it is forgetting the male female part. It is storing the classes of these. And now when I have stored the class of these, I cannot change the class of gender, because it is saying these values are not seen previously. So what I need to do is I need to make the right object for it. For example, LE. This object is used for embark, and this is object is used for gender. If you have multiple columns, you need to make multiple objects. So this is the mistake that I was doing. I will change it to embark. I think there are few changes. So it is just going to work fine. Let me just also write it here, df underscore test dot. Let me just write it here. Everything will work fine. Don't worry. Actually, I have created the changes, and if again I'm going to run this, then it is going to give me error because there is no string value. So I need to run it all again. So what I'm going to do is I'm going to just write restart and run all. So there was an error which I was creating. Uh, So cool. Everything will work fine. Cool. See, the changes have been reflected in our test also. Let me just tell you again. This object I'm using to change one column, and this object I'm using to change another column. Earlier, I was just using the same object. So it was first learning the values of gender column, and then the same object was learning the value for embarked column also, and it was forgetting the values that it learned in gender column. So with the help of this, I just wanted you to explain what is fit transform, fit and transform. So first we'll made the object to learn values and create changes. Then we only used uh, the object as it has learned value to only make changes.
Like when we label that what we say particular column, like defaultly for a female we got 0, for male we got 1. If I
Yeah.
would like to get female 1 and male 0, then how could I do, sir?
Actually, your doubt that I'm going to clear, your doubt I'm going to clear. Just wait a sec. Now I am having two objects which I have used to label in code. First object was le underscore s, capital S. So let me make it le. So this object has different attribute. For example, dot. So it is having many attributes. If I'm going to write parameters, get classes. Where is classes? Classes, yeah, over there. So it is going to tell me how many classes it is recognizing. So it is first it is recognizing female, and then it is recognizing male. You can change it. But the function what it does is if it gets a string, the first unique string it gets, initializes it to 0, and the second it initializes it to 1. If I will get another string, I will initialize to 2. Cool. Similarly, we can see it on the embarked also. See, it is getting three things. C is initialized with 0, Q with 1, and S with 2. There is no problem. You can initialize male 1, female 0. There is no problem. Cool. There is no problem. So, but now my data is well label encoded. The next thing we are going to do is we are going to study standard scalar. We are going to study scaling. We are going to study scaling. In scaling, what we does is, for example, if I am having my data over the range of 100, 1000. So what I will do, I will bring this data on a range of 0 to 1, 0 to 1, or -1 to 1, so that my CPU can compute more efficiently, just to increase the computation speed. For increasing speed, we are doing scaling. So we are bringing this data in the range of 0 to 1, or -1 to 1. So let me tell you how we can do that. For example, I am having data from range 1 to 5. For example, I'm having data in range 1 to 5, and I wanted to come between 0 to 5. So if I am going to divide it by my max value, so what it will become? It will become 1 divided by 5, smallest range, and the biggest range will become 1. So it is just scaling my data between range 0 to 1, or 1 to -1. So we are going to study scalars right now. So there are two types of scalar that I wanted to. One is standard scalar. Standard scalar. In a scalar, it is going to bring my data between the range -1 to 1, and another is min max scalar, which is going to bring my data in the range of 0 to 1. So most generally, you can prefer any of the scalar according to your need. So we are going to use standard scalar. See, there is a formula. It is z minus mean upon my standard deviation. This is the formula that this is using to bring our data into the range from -1 to 1, that we have studied before. In the starting of the classes, I made you a curve like this. This function represent this curve only. This function represents this curve only. So what it is doing, it is scaling my data between the range of -1 to 1. If you are going to read this documentation, you are really going to get quite inside this. So let us import this, and let us work. So it is also present in sklearn pre-processing. So what we are importing it from sklearn dot sklearn dot pre-processing import standard scalar. Let me just run it. Yeah, my standard scalar has been imported. So before using standard scalar, it is used generally in NumPy arrays, not in data frames. So we need to convert our data frame to NumPy array. So for converting our data frame to NumPy array, it was an easy task. So let us convert it. Explain. Uh, Let me just write something, then I'm just going to explain it to you. Okay. Uh, so, uh, so what I'm going to do is I'm going to assign y train. I'm going to assign y train. Oh, it is df dot test. Sorry. Let me just rerun this cell, and I'm going to tell you. Cool. So what I'm doing is I'm just assigning I will make this column as my Y train because it is my target column. As I have already told you, this my Y train, and I will make this all my X train because these are the features. These are features that I was referring in the starting of the class, and this is my target. Doing it is quite easy to do this. So what I'm going to do, I'm just going to write df dot iloc. Iloc is a function which is used to convert data frame into numpy array with slicing. So I need all the columns. I need all the columns. I need all the I need all the rows. Starting represent rows. I need all the rows, and I need columns starting from 1 to end. So what I'm going to write is I'm just going to write 1 and this. I need 1 to end. 1 to end, and then I'm going to write dot values because I need values. Similarly, here I'm going to do df underscore train. I need to specify it. Underscore train dot iloc. I need all the rows and I need 0th column. So I will just write 0th column dot values. And my testing set does not have a target column, so I will fully convert this to my X test. So df dot test dot values. I will just write values. Let's print out the shape also. My shape comes out to be cool. Cool. My target is a vector that I need a vector, and my features are 889 rows and 7 columns. See, these are 7 columns. 0, 1, 2, 3, 4, 5, 6. 0 to 6, 7 columns. Cool. If this is clear, repeat it once. Okay. I'm just going to repeat. What I've done is I have taken the data frame df.train. There is a function .iloc. What it does is with the help of .iloc, we can take out the specific column from data frame and convert it to numpy array. So starting to column represent here. Let me just let me just explain you a bit more clearly. So here we specify starting of the rows, starting of rows. So I will write SR, and here we at the back we specify ending of rows. Similarly, here I specify starting of the column, that from which column I want to take. Starting of the column, and here I will specify ending of the column. So I need this is my 0th column. This is my first. So I said I need from first to last. Cool. And in the second, I just specified a single column. That means I need the 0th column. Is it clear? Dishika, is it clear? Okay. So my values are all converted to numpy array. Cool. If there is a doubt, I can also print the type of it. Type of X train. Cool. Cool. Now, when we are talking of scaling, we generally perform scaling on our features. We only scale features, not the target. Y train is target, X train is features. So we are going to scale X train and X test. So for scaling X train and X test, it's quite easy. I will write X underscore train. Let me just see an example. It's quite easy. Yeah, we need to create an object of it. Cool. So for creating object, I will just write scale. I'm features for, I'm just scaling the features. So I will create an object scale X, scale X. So I will call the class that is standard scalar. Now it is having few of the arguments. You may copy true, you wanted to replace it with mean, you wanted to replace it with standard deviation. So all the parameters are already set by default. We did not need to pass any of the parameter. What we are going to do, we are going to just transform my matrices X train equal to. Before transforming, I just wanted to print the X train so that you can just visualize the changes that are being made. So let's print the starting 10 rows. X train, I need 10 rows and every column. Cool. Cool. It would be more good if I use the print here. Cool. Now you can see the values. This is my row 1. This is my row 2. This is row 3, row 4, row 5, row 6. So I'm getting the values. For scaling, I will just scale underscore X dot. Let me run the object and let me load the object. The object has been loaded. Now I can transform it. Dot fit transform. And it is asking me a value of X. So I will just pass X train. And similarly, I am going to use for X test also. Test. Cool. It is going to simply do the work for me. I just need not to do anything. I can just again print my X train. I need 10 rows and every column. See, it has scaled my value from, see here I am having the float value. It has scaled my value from -1 to 1. Few of the values are greater than -1. Otherwise, this scaling has performed quite a good task. It is well optimized. So what it is doing is it is just bringing the range close to 0 so that my CPU can compute task quite easily. It is just to compute task quite easily. This much we need to do in pre-processing. Now our pre-processing part is complete. So let me, the final thing is left here. So let me just do that, and then we are having a few time. Model fitting. Now we are going to see a model fitting. We are going to fit a model. Now our actual machine learn. This was our data analyzing. Now we are going to build a model. So we are not going to write code from scratch from today. If it is greater than -1, तो फिर से scale ना. Now you just only need to scale it once. Karthik, you just only need to scale it once. Only scale it once. Actually, now we have done all the things. Now we will see our first model, but we are not going to write today from scratch. We are going to write it tomorrow from scratch. So what I'm doing is I'm just we are using k nearest neighbor. K nearest neighbor. It is an algorithm that we are going to explore tomorrow. So from sklearn dot neighbor, it is present there. Neighbors, import k. See, it is giving us k nearest neighbor classifier and k nearest neighbor regressor. So our task is a classification problem. So we are going to import classifier. If our task has been regressing problem, continuous data, then we have to call regressor class. Today our task is classification task. So we are going to call classifier. So let me call the classifier. The classifier has been called. Now I'm going to write 3 lines. After that, I'm going to explain you what they are doing. Yeah, I'm just going to write these 2 lines and then I'm going to explain you. Cool. Uh, cool. Uh, uh, what I'm doing is I'm just calling a algorithm that has been specifically written in sklearn, algorithm that we are going to see tomorrow. So there is no need to panic. We are going to see it tomorrow in great depth. So today I'm just calling that algorithm, and this I'm creating an object. I'm having I have created an object called CLF. I can give any name to it. So I have created an object CLF, and this line is really important. This line is doing all the magic behind. This line is training our object our object onto features and target. So let me explain you. When I have run only this line, when I have run only first line, so when I have run only first line, then it has created me a model which do not know anything, which do not know anything. Then it is making the model to understand what feature belongs to what class. Are you getting? For example, I am having a small baby, and on the first day, I take an apple and I show it to the baby, and I tell him that this is an apple. On the next day, again, I go to the same baby and I show the apple and I say, this is an apple. And I keep repeating this thing for 29 days. So what the baby is doing for 29 days, first it will recognize, the apple has red color. On the next day, it will recognize the apple has this shape, and then the day by day the baby is going to recognize more of the features of the apple. So the same thing we are doing is we are just first providing the features, and then we are telling the model that this feature belongs to this target. For example, if I have multiple target, I have apple, oranges. So I will show the features of apple and I will tell the baby that this is an apple. On the next day, I will show the features of orange and I will tell the baby that this is an orange. So the model is learning. In this step, the model is learning. See, this is the difference. We are not writing any code. We are just providing the data to our model and it is learning itself with the help of that data. Are you getting the concept? If this is clear, right? Okay. Otherwise, we have two more lines to write. Two more line of code is left, and this is going to finish. After this, we are going to generate data. Now we have talked about validation. So for validating data, now I just wanted to know that I'm going to just give the features to my model, and I'm going to ask the model that this feature belongs to which category, which target. So for doing that, I am just creating an object pred, and I'm just going to write object name clf dot function called predict, 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 simple function predict, and I'm going to pass xtrain. I would have passed x test, but I don't have the value of y test, so I won't be able to compare. But in the future class, we are going to pass here x test generally. So this is going to give me the prediction. See, my model has predicted the output of everything. So let's see what my model has predicted. So my model is predicting 0101010101. Cool, cool. I'm just commenting it out so that the output just clears out. So my model is predicting cool. Now what I'm having predicted data that is represented by P, and I am having target data, the actual output. This is my actual Y train, because I am making it to predict on X train. So I am having actual output as Y train, and my model is predicting values as P. So what I need to compare, so my model is predicting as 0, 1, 0, 1, and I am also having my actual target values. So for example, my actual target values are 0, 0, and so on. So what I'm going to do, I'm just going to compare this value. If this is equal to this, then my model is predicting correct. If this is not, for example, if this is not equal to this, then my model is predicting wrong. So we are just going to check the accuracy of our model. For checking the accuracy of our model, what I'm going to do is I'm just going to compare both the values. Pred double equal to y train. So let us see what output they present. So see, they are giving true, false, true, false, true, false. So they are giving true where both values are same. They are giving false where both the values are different. So if I am just going to call dot sum, so it is going to give me a sum of all the trues, and hence it is going to give me total correct predicted values. So it is giving me a sum of cool 763 correct outputs, correct predicted value. It has given me 763 correct predictions. Let's check out how many total predictions were there. So total I can check out by ytrain dot shape or xtrain or pred dot shape. Both of they have same shape. See, my total predicted values were 889 and my correct predicted value is 763. If I divide this value by total predicted value, then I am going to get the accuracy of my model. So what I'm going to write pred dot shape. So let's check out the accuracy of my model. So my model is giving me accuracy of 0.85. Is it clear? If it is clear, just write pred. If it is clear, just write pred. Pred. Just write it. If it is clear, otherwise you are having doubt, I can repeat it. If you are having doubt. But first I have done is, first I have trained my model. Then I have given him the features and I have asked him the output. So yeah, Bhupender is saying repeat. Okay. Okay, sure, Bhupender. So Bhupender, is it clear till here? If it is clear till here, right? Yes. If it is clear. Yeah, cool. I have created a model. I have created a model and I have trained it, trained the model. Now my model knows about. I have provided him few of the values. Now my model is an intelligent model. Now my model has become intelligent. I have taught him something. Initially, it didn't know anything. Then when I called dot fit, then I taught my model uh, that this feature belongs to this target. I have taught my model this. After that, what I have done is now my model has become a bit intelligent. And now what I have called a function predict, in which I am only passing features, only passing the features. I'm only passing features and I'm asking my model to tell me what output do they belong to. I'm asking my model, uh, tell me what output they belong to. For example, I can just print the starting 10 features, a starting 10 target. So my starting 10 targets are 0, 1, 0, 1, 0, 1. And I can also print actual values. My actual values are 10 actual values. Now we will get more into it. So my model is predicting 0 and my actual value is also 0. My model is predicting 1 and my actual value is also 1. My model is predicting 1 and my actual value is 1. Let's see where my model is predicting wrong. So the model is quite intelligent, and as we can see, it is giving us accuracy of 0.85. So starting 10 values, it is predicting exactly correct. So my model is giving me accuracy of 85. Next is our data creation task. So for data creation, what I'm going to do is, let me just tell you that in Jupyter. As we have only 25 minutes left, so I'm just going to iterate over the code, as we are not necessarily using it in our after class. It is just for knowledge. So just feel relaxed and just sit back. We are not going to use that further, but it is for knowledge and it is in syllabus, so I'm telling you that. So I would just, you don't panic. So we are not just going to write any of the code. The written code, I'm going to explain it to you. Cool. So let's. Uh, Wait a sec. Where is that? This file. Actually, it is not that important. Otherwise, I would have told. I would have written code for you. It's not really important. It's not really important. I'm also not having few of. Cool. Uh, cool. So let's get into it. My scikit-learn is already installed. I've already told you, if you want to install anything, you can install it like this. As we have seen, we have seen a classification problem where we classified between survived and not survived, between the people who survived in Titanic tragedy and the people who didn't survive. I have also told you about the regression problem, what are regression problem and how you can just deal with all the regression problems. We are going to see what are blobs and what are moons. It is actually for data creation. There is no hi-fi math that you want to understand. It is generally for data creation. Otherwise, I would have just written. I would just have given you one-on-one code interactive session. It is not of worth investing time. The things we have done today are worth of investing time. For example, like data pre-processing, it is really important. So what this does is here we are importing few of the functions like make regressor, make classification, make blobs, and make moons. Blobs and moons that I'm going to tell you as we move further. So these are the functions that we are, as we are creating a data set, so they are present in sklearn.dataset. So let me just run. Now, why I have told you to move to collab because of this thing, as it is taking quite a lot time in running things. If I would have continued that thing in Jupyter, then it would have taken more time to finish. So that's why I want you to move to Collab and Kaggle. So yeah, it has completed its running. And we have also imported two packages, Matplotlib and NumPy. Matplotlib and NumPy, we have imported two packages. So we are going to, so that we can just visualize things. So first I am going to make regression, going to call regression data. So for calling the regression data, as I have already imported the function, I'm just going to call this function. So this function has few arguments. How many rows you want, how many rows you want, how many features you want. Features means column. How many columns you want, how many columns to be informative. That is, how many columns you want to have a correlation. And the last column is noise. How much distorted data you want. So noise is quite less, so you are going to see a straight line graph. So if I run this, I and this, then what I'm getting is I'm getting a X shape with 400 comma 1, that is 400 rows and one column. Y shape is only 400. Y is my target. Y is my target. So if I plot, for plotting I am using scatter plot, X comma Y, and color I am going to give blue. Blue looks quite cool. Cool. So now you can see that all points are plotted. If I'm going to reduce the noise, for example, let me just make noise as 0. Then it is going to give me a graph of almost straight line. Are you getting the difference? So it is just used for once you have written your model and now you want to verify how my model is predicting, it is just for that stuff only. So if you are going to pass noise, it is going to generate data randomly. Now let's see one of our classification that we have studied. In this, what we are going is we are taking XC, that is the features of features, and YC is target. It is of our classification problem. You want, I can just plot it also. We are going to plot it also, and then you are going to visually see what classification is. So classification, I need 400 data set and I need two feature, x1 x2. I need two feature x1, x2. I need two classes only. Let's see for two classes, and then we are going to see it for four classes. Let's see for two classes. For example, I only need two classes, and one more thing. I want my both column to be informative. Both column to be informative. I can also do something which I think you might have not tried. I can just press enter. I can also pass arguments in this fashion. If I'm not able to see all the arguments, I can also pass arguments in this fashion, but the argument should be intended. So the Python will recognize all these arguments belong to same function only. So I want two number of features should be two, classes should be two, and cluster per class one. I want both classes to be informative. So if I run it, if I just type x dot shape, so it is just giving me two classes, two columns, and it is also it is also giving me two classes. If I just write, for example, let's see what YC is. YC 10 rows. See, it is giving me two classes, 0, 1, 0, 1, 0, 1. Cool. So let me just, so it is giving me two classes, and I can also plot it. See, the classification problem has only two classes. Here I just only need to classify. If I'm going to increase my classes to 4, actually classes to 4, then I'm going to see four blocks there. Let me also print YC. See, now I'm having 0, 2, 1, 3, 4 values I'm getting. And let me print it out. See, now I'm getting four color cluster. This is my class 1, class 2, class 3, and class 4. So it is not of generally use. Blobs are used for clustering algorithm. The next type we have studied. Blobs just use. They are unsupervised learning. They are used for unsupervised learning. They will generally cluster. For example, this is my one cluster. This is my one cluster. This is my one cluster. This is my one cluster, and this is my one cluster. Also, let me explain you a few of the things with the pen. So it is not that important. N centers means how many centers you want the cluster to be. For example, one of my center would be this, one of my center would be this, and one of my center would be this. And similarly, one of my center would lie on this, and one of my center would lie on this. So I'm getting all the 5 centers. So centers means how many centers you need. Features means number of columns you need, and n sample means number of rows that you want to need. There's nothing hard maths here. It is just generally used for getting the data. It has given me the four clusters that I need. Now let's see another thing. It is blobs. Moons. So what moons does is it gives me data in the shape of moons. For example, I can see this as a moon, and I can see this as a moon. For example, I can just draw two moons here out. This is my one moon, and similarly I can figure out I am having another moon also. So it is going to give me data in shape of moon. That's why it's called moon's data. So let me tell you about this. These are n features, number of rows. I want data to be shuffled. The noise should be 0.2, so that's why they are overlapping. If the noise is 0, they won't be overlapping. For example, let's try it out. See, they are not overlapping anyone. So cool. I think this you have. Now this is important. This is important. Nothing is important. This is important. For example, 2. No, let me just write 1. Create few changes and then explain it to you. One cross one, 1 cross 1, 1 cross 1, 1 cross 1. So I need only 4 cross 4. Let me run it out. PLT dot subplot C equal to YC. Oh, wait a sec. Let me just figure it out. It is giving me error here. Let me just yes. Cool. I'm going to tell you what the error I was making. Sure, cool. So actually what here is happening, if I wanted to create a plot, if I wanted to create a plot containing more than one plot, for example, this is one plot, this is my second plot, this is my third plot, this is my fourth plot. If I wanted to create more than one plot in my one plot, so what I'm going to use is I'm just going to use plt dot subplot. uh, uh, for plotting subplot, I just need to specify figure size. I want a 8 comma 8 means that the grid size should be 8 comma 8. The grid size should be 8 comma 8 and plt dot plot. Here this is my grid size that this plot should come in, and this is the plot number. And I will simply this line will specify where you wanted to plot this plot, and after the next line is simply in the next line we are just simply plotting our figure. In this line we are also in the next line we are again telling it that this is my second plot and the grid size should be 2 comma 2, and then again we are just plotting our plot. In the next plot, we are telling the grid size and the plot number, it is 3, and we are plotting our plot. And similarly, this is my plot number 4, and I'm plotting my plot. So this is happening here. We are going to see it in detail tomorrow when we are going to see the MNIST data set. Then we are going to create much subplots. We are going to create many subplots out of that. In the future classes, we are also going to split our data. We are also going to split our data. For splitting our data, we also import a function from sklearn dot model selection import in underscore test. This is the function name that we are going to need in future classes. What this function does, for example, if I am having a data and I am having 100 rows. So here I am writing rows. It is just like my shape. I'm having 100 rows and suppose 2 columns. and I wanted to divide this data, and what I will do, I will divide this data into two parts. So one data will be my training data that I'm going to train my model on, and my rest data will be testing data that I'm not going to provide to my model, because I want to keep this data as fresh data, and the model should have no previous knowledge about it, so that I can get a more realistic accuracy of my model. So what I'm going to do, I'm just going to break it into training and testing. For testing, I'm going to give 80% of my data to testing and 20% data to training. So this we can do just in simple steps. This is also a part of pre-processing, and this we can do by just let me have few of the data. Let me take the data which is available. For example, we are having XY. Cool. We are having XY. Cool. So what I'm going to do, I'm just going to write X underscore train, comma, Y, sorry, X underscore test, comma, Y underscore train, comma, Y underscore test. And I'm simply going to call this function train test split. This function has quite good arguments. So let us first see what arguments this function has. This function has, it needs array that you want to split, and it needs test size or train size. If you provide test size, it will all calculate train size by default, and if you are going to provide train size, it is going to calculate test size by default. And this is random state. If you are not going to specify it, it is going to create both sets in random order. First it is going to shuffle that data, and then it is going to create divide that data. So by default, shuffle is true, as it is going to shuffle that data. So these are the important parameters that I wanted you to know. Nextly, let me just show you how this works. So what I'm going to do is, I'm just going to provide my X, comma, Y and test size. Test underscore size. Test size to be 20%. For providing 20%, I will write 0.2. And see, now I can just, wait a sec. Let me close this. So now I'm just, as I've run this cell, I need a next cell. Just X dot shape. Cool, and I'm going to print X train dot shape, comma, X test dot shape. So you can see initially I was having 400 rows and one column. Now my X train is having 80% of data, that is 320 rows, and my X test is having 80 rows, that is 20%. So it is just dividing our data into two sections that we will going to use from our next class. So I think this was of this part of pre-processing that I didn't tell you, because today we were not dividing our data because we were having so less data. We were having only 891 rows, and 891 rows is so less data. So that's why I didn't wanted to divide it into two parts. Otherwise, if I am going to divide my data further, then my model will learn on small data, and it is going to give me bad outcomes. For example, there is one rule of machine learning. there is a one rule of machine learning that that you must really know. If your model is performing bad, for example, my model M is performing bad, so I can do two things to improve the accuracy of my model. Firstly, if I increase my data, INC data. That is, I can train it on more data, then my model accuracy will improve. Otherwise, I would have to hypertune its parameter, hypertuning, that we are going to see as our class is going to progress. We are ending the session. Cool, guys. Okay, bye. Thank you, guys.